Hello all, welcome back. Hope you all watched my previous videos, and in today's session let me explain you the fifth and sixth lab assignment of DDCO. So next fifth question is design Verilog HDL to implement decimal adder. We have to write a Verilog HDL program to implement decimal adder. First of all, what is decimal adder? Decimal adder is a method which is used to add binary coded decimal numbers BCD. It is also called BCD adder. Okay, what does BCD stands for? Binary coded decimal numbers. Here you can see the circuit. A, it will have 0 is to 3, zeros to 3, and B value also varies from 0 is to 3, which indicates that this is 4-bit numbers. Okay, A value varies from 0 to 9 and B value varies from 0 to 9, and some value varies from 0 to 18. How 0 to 18 means? Here A value from 0 to 0, A and B value, initial value is 0 and 0. So 0 plus 0 will be here 0, and A and B final value is 9 and 9. So 9 plus 9, it is 18. Here I am not considering the previous output. If we consider previous output, sum will be 0 is to 19. How 0 is to 19? 9 plus 9 plus 1. 1 from previous output. Carry from previous output. So it will be 19. Next, let we move on to Verilog code. So we have A, B as input, sum as output. A and B value varies from 0 to 3. It has 4 index positions, 0, 1, 2, 3, and sum has 5 index positions, and assign sum is equals to A plus B. This is data flow Verilog module. And while we are giving values to A and B, if on clicking on A, we'll have the options like a force value, right? When you will get the display to force the value to your inputs, above force value, you'll have value radix option. In value radix, you have to change it to unsigned decimal. It will be usually in binary. In previous questions we have done it in binary. So in this question what you have to do is you have to change it to unsigned decimal. Okay, then give value to your inputs and then take the output. So this is the output. So this is the output. Here A value is given as 0110, which means that A naught value is 0. From here, from right to left, it will the value comes from right to left. This 0 is A naught, this one is A1, this is A2, and this is A3. Okay, and B also, B naught value is 1, B1 value is 0, B2 value is 1, and B3 value is 1. Sum of this will be 0 plus 1, it is 1. 1 plus 0, it is 1. Then 1 plus 0, it is 1. Then 0 plus 1, it is 1, and nothing, 0. Okay, we can also ignore this one. We can also write it as 1 1 1 1. Okay, so this is the input, this is the input that we are going to give, and this is the output that you will get. Next we shall move on to sixth question. What is sixth question is design Verilog program to implement different types of multiplexer like 2:1, 4:1, 8:1. So first of all, what is multiplexer? Multiplexer is also known as data selector, and the word multiplexer indicates that it is to create multitude. Okay, first, what is 2:1, 4:1, and 8:1 multiplexer? In 2:1 multiplexer, we'll be having 2 inputs and 1 select input and 1 output line. 2:1 multiplexer will be having 2 inputs, A0, A1 or D0, D1, any variable name we can give, and select line will be having 1 select line, S0, and output Y. In 4:1 multiplexer, we'll be having 4 input lines, A0, A1, A2, A3, and we'll be having 2 selected input lines, 2 select lines, that is S0 and S1, and 1 output lines. 4 inputs, 2 select lines, and 1 output. In 8:1 multiplexer, we'll be having 8 inputs from A0 to A7, A1, A0, A1, A2, A3, A4, A5, A6, A7, and there'll be 3 select lines, 3 input select lines, S0, S1, S2, and 1 output line, that is Y. Back to question, 2:1 multiplexer, as I said, we'll be having 2 inputs and 1 select line and 1 output. So select line value will be 0 or 1. If the value of select line is 0, then it will be pointing to D0. If the select line value is 1, then it will be pointing to D1. So this is the program which tells the same. Inputs are D and S. S is select line and D is input, Y is the output. Select line 0 is to 0 because it has only one, S naught. Then D value, D naught and D1. 1 is to 0 and output is Y. And there are 2 cases. S value can be the 0 or 1. Zeroth case, when it is 0th case, Y value will be D of 0, which means that when S value is 0, as I said, it will be pointing to D naught. So Y value will be D naught. Or else, if S value is 1, then it will be pointing to D1 and Y value will be D1 directly. This is 2:1 multiplexer. Then what about 4:1? In 4:1 multiplexer, as I said, we have 4 inputs and 2 select lines and 1 output. 4:1 multiplexer. Select line 0, 0, 0, 1, and it can be 1, 0 and 1, 1. If S0 and S1 value is 0, 0, then it will be pointing to D0. So Y value will be equal to D0. This is case 1, case 0. Case 0 is Y will be D0. Then case 1 is when the S0 and S1 value is 0 and 1, it will be pointing to D1 and Y value will be equal to D1. Then when S0 and S1 value is 1, 0, it will be D2 and Y value will be equal to D2. When S0 and S1 value is 1, 1, it will be pointing to D3 and Y value will be equal to D3. This is what? Case 0, case 1, case 2, case 3. These are the 4 cases. And this is all about 4:1 multiplexer. So next is 8:1 multiplexer. In 8:1 multiplexer, we have 8 inputs and 3 select lines and 1 output. Okay, so D0, D1, D2, D3, D4, D5, D6, D7 are the inputs. S0, S1, S2 are the select lines. S0, S1, S2 can have 8 combinations. First combination can be 0, 0, 0. So when all 3 select lines values are 0, 0, 0, then it will be pointing to D0 and Y value will be equal to D0. If it is 0, 0, 1, then it will be pointing to D1. As it is, if it is 0, 1, 0, then it will be pointing to D2. And when it is 1, 1, 1, all the 3 values are 1, 1, 1, it will be pointing to D7. Okay, so there are many other combinations for these also. If it is 0, 1, 1, it will be pointing to D3. If it is 1, 0, 0, it will be pointing to D4. If it is 1, 0, 1, it will be pointing to D5. Okay, likewise, if it is 1, 1, 0, it will be pointing to D6. Okay, these are the 8 cases. 0, 1, 2, 3, 4, 5, 6 are the 8 cases for Y values. This is 8:1 multiplexer Verilog code. These are the outputs for 2:1 and 4:1 multiplexer. If S value is 1, as I said, it will be pointing to D1. D1 input. For D1 the value is 0, for D0 the value is 1 as given as input. So what will be Y value? As select line is pointing to D1, what is D1 value? 0. So Y value will be 0. So it came. Okay, then likewise in 4:1 multiplexer, a select line value is 1 1. That means it will be pointing to D3. What is D3 value? It is 1. This 0 is D0, this 0 is D1, this 1 is D2, and this is D3. So Y value will be equal to D3, which is 1. Then it is 8:1 multiplexer output, and select lines inputs are, combinations are 1 1 1, which means it will be pointing to D7. What is D7 value? It is 0. Okay, so Y value will be equal to D7, that is it is equal to 0. Hope you got to know how this is arranged. So from left to right it will be D7, D6, D5, D4, D3, D2, D1, D0. From right to left it is D0, D1, D2. Okay. In select lines also it will be from left to right it will be S2, S1 and S0. Okay. So this is all about the sixth question, how to solve 2:1, 4:1 and 8:1 multiplexer. Hope you all got to know. Keep watching my video. I'll update the next remaining 2 questions in my next video. Do subscribe the channel for more updates. Thank you.